Assalamualaikum to Dr. Maliza. This is our video presentation for our project. So we are from group 7. This is our group members. So our OS project, we are using Oracle VirtualBox, and then we are using Debian for our server and our client. So we will proceed to the demonstration. We will go to 2.0, which is design and configuring network.
Okay, so my name is Muhammad Fakrul Haziq and I will be presenting about our first 2.0 from our report. Okay, so first of all, to install the server and client, we have to go to tools, and then first we have to create the internet adapter. Okay, so for our group we have already created the internet adapter, which is this one, is number two, and then the first one is default one, which means that when you installing the Oracle VirtualBox, you will get this as a default. So we need to create a new one and then put our IP address that according to our question. Okay, so this is the IP address that have been given and IPv4 network mask. And then we have to go to the HTTP server and then also put the IP address that given to us according to our question. And then after that we have to create it, and then you will see this internet adapter step number 2. And then we need to create the server. Okay, so we open the new, and then first we have to choose our Debian. So this project we choose the Debian 12, and then we choose Linux Debian because obviously we are using Debian. And then we put the name server. Okay, and then we have to go to and then install, put our username as server, our username group 7, and then our server is server, our name is server, and then the password, put the password. And then the hardware is just using the default one, and then hard disk also use the default one. Okay, so I already make the server before, so we should go and look. Okay, so after creating the server, so we have to make an update to its source list. Okay, so the source list is what we have to update our virtual box Debian to according to our source list. So we have to update it first. Okay, so enter this command and then put password. So at first it will display only these two lines. Okay, so we have to make an adjustment and add another two code, like this third one, the line, and then the fourth line. Okay, okay, with this new line, it will improve it will make an update to our Debian. So Control O, and so right now the command is save, the command. Okay, then Control X. So we have to make an update lah. So enter the sudo apt update. So the Debian will update it automatically. Okay, then sudo apt upgrade. After entering the command update, you need to put the sudo apt upgrade to upgrade your Debian according to your update. Yes, Y, enter. So right now our server is already been update. Okay, so this means that the update is successful. So I forgot to mention that during this one, so we have to change. You have to change our network. Okay, our network. So we have to go to adapter 2, and then we have to choose a host on the adapter. Okay, and then we choose the number 2 one, the number 2. So this is the for server only. Okay, server only. We have to make this adjustment to the DBNet host on the adapter, and then virtualbox attached to that we created earlier. Okay, during the tools one. Okay, after we done configure update in the server, we have to do the same. Okay, we have to create another file that called client for our client, and then we also need to put the command.
Welcome to the presentation video, Dr. Malisa. So my name is Thiruselvam and I will be presenting to you about the third part of this project, which is Dynamic Host Configuration System, or in short, also known as DHCP. So what is DHCP and what does it do? So DHCP, also known as Dynamic Host Configuration Protocol, is a client-server protocol that automatically assigns configuration information such as IP, subnet mask, default gateway, and DNS server to the connected devices on the network. Not just any one or two networks within the network, but all the devices in the network. So when implementing such DHCP, it ensures that each device gets a unique IP address, which also prevents conflicts on the network. So, why do we need to implement such DHCP in our network in this virtual machine? So, we need to implement as it is a crucial protocol for reducing errors, enhancing network flexibility, and simplify IP address management. So, let's say I have this one network, and then by implementing the TCP, it assigns a unique IP address for each and every device that exists or that's a part of the network, so that when there's a communication between two devices, there is no confusion occurs between two devices. So, for example, let's say if I do not implement DCP, and then there might exist two devices which shares the same IP address. And if let's say there's an external device which tries to communicate with any of the two devices that shares the same IP address, it might confuse to communicate uh, with the to which device it has to be communicated with. So in order to prevent that, that's why we need to implement DHCP in our network. So there are several steps to configure DHCP on both of our virtual machines in our network, which are named client and server. Without further ado, let us discuss on how to configure DHCP in our server. So as you can see on the terminal of our server virtual machine, we need to type this command sudo nano slash etc slash network slash interfaces. As it suggests, when we execute this command, it will bring us to the nanotext editor for the interfaces of the network. So currently we are in the nanotext editor for the interfaces of the network. As you can see, it is already been set to the in a way that the project wants us to be, which already specified in the project specification. As you can see, the interface ENP0S3 is set to DHCP, while the interface ENP0S8 is set to the static mode with the address 192.168.1.254 with a network mask of 255.255.255.0. To save the configurations that has been made in the nanotext editor, we need to press Ctrl Alt following by Enter to save and to exit from the Nano text editor, we simply press Ctrl X. As you can see, we are back to the terminal. So previously we have done configuring the interfaces ENP0S3 and ENP0S8. Now we need to change the states of them to down followed by up in order to restart them, so that the changes that has been made in our server virtual machine takes place. So to do that, we need to type sudo ip link set device, so interface name. So first we do this for 0 s3 s3, and then we change the state to down. Do the same command to s8. All right, now that both of our interfaces are set to down, we need to set them back to up again. So for ENP0S3 up, followed by ENP0S8 up. So now we have done setting the states of the both of the interfaces from down to up. Let us execute the command sudo systemctl restart networking to ensure that we actually restart the changes that has been made to the network. So the network will be restarted by executing this command. So it might take some time, so you just wait. All right, so now it has already processed the command. So now we have to type ip address as a command to check the ip address that has been assigned to the interfaces. All right, as you can see, we have both of our interfaces ENP0S3 and ENP0S8. So as you can see, our IP for ENP0S8 is 192.168.1.254 with a subnet mask of 224, and that's pretty much of it. So that's the current progress for the server virtual machine, client virtual machine. So as we have done, what we've done in the past for the server virtual machine, we need to execute the command sudo nano slash etc slash network slash interfaces. As what it suggests, it will bring us to the nano text editor for the interfaces of the network. So now we have the current nano-text editor for the interfaces of the network for the client virtual machine. As you can see, it has already been set to the way that the project specification suggests us to do so, and where the interface ENP0S3 is set to the DHCP. So to save that, simply press Ctrl O followed by Enter, and to exit press Ctrl X. So that's all for the client part. Alright, back to the terminal of the server virtual machine. So as you all know, we have already declared the DHCP on both of our client and server virtual machines. Now we have to install the DHCP as described using the command sudo apt install isc-dhcp-server, and by doing so it will install the DHCP server. As you can see, it's already been installed. So let us proceed to the next command, which would be sudo nano slash etc slash dhcp slash dhcpd.com. So what does this command will do? So as we already installed the DHCP that has been configured um, previously, so since it's already been installed, now we have to configure the IP address or provide the IP address in this directory. So that's why we need to execute this command so that we can allocate or provide the IP address. So initially, when you open this, what is it called, nanotext editor, the default list type and the max list type will be a actual command. So we need to change it from command to command by placing hash in front of the commands. So as you can see now, once we place the hash, we need to include this extra set of codings for the nanotext editor. So we need to type subnet 192.168.1.0, which is the subnet, and the network mask 255.255.255.0, and then we place a set of curly braces, and within the set of curly braces we need to declare the range for the DHCP to take place. So for this case, we will allow the range to be 192.168.1.5 until 192.168.1.10, as what it has been mentioned in the project specifications. As for the router option, we need to set the IP address to 192.168.1.254, and that's pretty much of it. And once we are done with everything, we need to press Ctrl O to save and followed by Enter, and to exit Ctrl X. So now we have already set the range for the DHCP to take place. We need to uh, open the nanotext editor to the file etc/default slash isc-dhcp-server. The isc-dhcp-server is the DCP that we have installed earlier. So in order to do that, we need to type sudo nano slash etc slash default slash isc dash dhcp dash server. So once we have successfully typed out the command, we need to press enter. So as you can see, it shows the two commands, which are interfaces v4 and interfaces v6. As for the interfaces v4, we need to set it to enp0sa as what it has been mentioned in the project specification. And for the interfaces v6, we leave it null or empty for the time being. As usual, Ctrl O, enter to save, and Ctrl X to exit the nanotext editor. So now we have know that we have already successfully installed the DHCP server previously before, and now it is time for us to task that start testing the service in virtual machine. How can we do that? So there are two commands. So the first command would be sudo space systemctl start isc-dhcp-server. So what does this command will do? This command will start to run the DHCP server that has been installed earlier on. So you press enter. Now we need to check the status of the server, DHCP status that has been downloaded. So to do that, we need to type sudo systemctl status isc-dhcp-server, and we need to press enter. Back on the terminal on client virtual machine, now we need to change the states of the interface enp0s3 to down and up. So we can do that by executing the command sudo ip link set wise enp0s3 down, enter, followed by R. Once we've done that, we need to restart the network for the changes to take place. So we can achieve that by um, typing sudo IP, actually no, sudo systemctl restart networking. So once we enter, there's already causes the network to restart. All the changes had in the network implemented will be applied in throughout this command. And to check that, we need to type IP address to check what is the IP that has been allocated to the interfaces. As now we can see in the second option, at where it carries the ENP0S3, there is an IP address of 192.168.1.8 with a CIDR of 24. What does it suggest? So this IP address right here, this is the unique IP address that has been given by the DHCP for the interface ENP0S3. So as we all know, ENP0S3 is said to be the DHCP interface by default, and it has the IP address of 192.168.1.8, which also falls in within the range of 192.168.1.5 till 192.168.1.10. So as it falls in within the range, we can tell that the DHCP has successfully been configured. So upon we already retrieve the IP address, now we already got the IP address which can be tested for later on. So this is the IP address received by the client. As you can see, after configuring all the DHCP, now we are back on our server virtual machine, and in order to uh, test the either the installed server DHCP server takes place or not, is applied or not, we need to apply this or execute this command: sudo systemctl start isc-dhcp-server. So when you press enter, it should start the DHCP server that has been installed and applied in the server virtual machine. So to check the status, we simply copy the same command, but instead of start, we need to replace it with status. So when we enter, you can already see that it's several lines of results pop up, which suggested the DHCP has been successfully applied the server. So we end this process first. So now that we have already know the status of the DHCP server that has been installed and applied is successfully connected, next we'll move on to testing the validity or the DHCP that has been installed in the both of in the network is successful or not. All right. Now we already know we have done the what do they call DHCP configuration on our network, which is on both client virtual machine and also the server virtual machine. Now we need to test whether the DHCP server that has been applied on both virtual machines takes place or is in effect or not. And to do so, we have to carry out several testing procedures in order to check the validity of the DHCP configuration that has been done throughout this network. So for the first, now we have to ping the client's IP address, which is provided by the DHCP server itself from the terminal of server. So we can achieve that by uh, executing the command ping and the IP address that has been given by the DHCP earlier on, which is 192.168.1.8. So when I enter, it should be able to ping to the client. So as you can see, it can successfully ping to the client. So what we can do now, uh, we end the transmission of what do they call the communication or the packets transmitted. So it can definitely ping to the client. So which means that there is a communication, or there is a successful DHCP server connection in between server to client. As for the second part of the testing procedure, now we are at the terminal of the client virtual machine. From here, we need to ping to the server. So as we all know, we already know that the IP address of the server equivalent to 192.168.1.254, as we all already configured earlier on when setting up the. For the third part of the testing procedure, we need to go to the root for the virtual box, so which can be done by the execution of command of sudo su dash. This should bring us to the root of the virtual box of the server. From here, we need to execute the command dcp dash list dash list. Wait, list. So what does it this command will do? So this will ensure that the client can use the DHCP service by executing this command. So when we enter this command, it actually shows that the hostname client can actually read the leases from the library from the DHCPD within the network. So as you can see, the DHCP is applied to the client and to the server as what the table shows. So to proceed with the next part of the testing procedure, we need to go back to the server terminal. So we can do that by doing group 7. So now we're back to the terminal of the server. As you can see, now for the fourth step of the testing procedure, we need to ping Google to test the connectivity between the server to the network or to the internet. So as we all know, we are already successfully implemented or applied JCP server. So it must be allow us to access to the internet. So what we can do is that we can ping www.google.com. So when I press enter, it should be able to ping to the Google. So as you can see, it is very much live that we can ping Google. So it is appropriate to end the pinging process by Control C. So all of the packets has been successfully transmitted, and to show that it has a connection between the server virtual machine to the internet, we are able to prove that by opening or surfing Google from our web server. So as you can see, we can search Google. The Google is very much alive, so we can use Google from our server virtual machine because there is a network or there's a connection established between our network. I mean the server virtual machine to our internet. So that's more of about the test procedure of server. All right. So as you can see now, for the last step of the testing procedure, now we are at the terminal of the client virtual machine. For from here, we need to ping to Google by the website of www.google.com. So we try to ping Google from the client virtual machine. So ping www.google.com. So it might take some while to show the results. So at as we can see, it shows that ping www.google.com has a result of temporary failure in name resolution. Why does it show like that? It is because the DHCP applied does not allow the access to the internet from the client virtual machine. So to prove this result that is being provided by terminal, you can actually open the web browser of the client from the client virtual machine and try to open Google. It might take some time to load, so let's just wait for the result to pop up. Alright, as you can see, it shows that we are having trouble finding the site. This also suggests that there is no connection established between the client virtual machine to the Google. Thus, it is evident that there is no connection or access allowed in between client virtual machine to the internet. So I believe that's the end for the testing procedure and for the whole part of part 3, which is dynamic host protocol configuration protocol. I think that's all from me. Thank you.
Hi, my name is Mirsia Nawan, and I will continue this presentation by demonstrating the Secure File Transfer Protocol. Secure File Transfer Protocol (SFTP) is a network protocol for securely accessing, transferring, and managing large files and sensitive data. It runs over the SSH Secure Shell Protocol, ensuring that the data transfer is encrypted and secure. It also allows for file operations such as uploading, downloading, renaming, deleting, and changing file permissions, all in a secure environment. So now let's move on to the step-by-step configuration. So for the first step, we have to edit the sources.list file using Nano Editor. So type this command and it will open the Nano Editor so that you can add the sources that we need. This is the initial content of the file, so we have to add the rest of the sources list as shown in this picture. Then save the file using Ctrl-O plus Enter, and then exit the file using Ctrl-X. Next, to update the local package index with the latest changes we've made earlier, run command sudo apt update and sudo apt upgrade to upgrade the system. Next, run command sudo su to switch to the super user, which is the root, so that we can have the full administrative control over the system. After that, run command sudo apt install OpenSSH server to install the OpenSSH server package on a system running on a Debian-based Linux distribution. To verify that the OpenSSH server had been installed successfully, run this command. Next, we have to exit the root server and go back to the group 7 server home so that we can execute the next step. So for the next step, we have to run the command sudo systemctl start sshd to allow remote users to connect to the system using Secure Shell Protocol, which provides secure encrypted access to the machine over a network. And we can also check the status by running this command. And then we have to go back to the root server to create a new directory named sftp under the srv directory using this command.
since we have created the directory before, so it will display a message that the file already exists. So next you have to create a new group named SFTP users. For the group as well, we have already done it before. So it will display that the group SFTP user already exists. And also add a new user named GRP7SFTP.
We have to run this command to assign the user we created earlier, which is the GRP7SFTP, to the group SFTP users. Next, run this command to make sure that the user do not log in but still have access to the system. After that, we need to edit the SSH server configuration file by using this command. And then go to the bottom of this config file and stop at the part of override default of no subsystem. So initially, you will see this sentence here, but we need to change it to internal SFTP. And then remove the hashtag from the match user SFTP users until the last line, which is the first command, and save the file using Ctrl-O plus Enter, and then exit the file Ctrl-X. After making changes to the SSH configuration file, run the command sudo systemctl restart sshd to restart the SSH service and apply the changes. Then, to check whether the changes made in the SSH configuration file have taken effect, run command sudo systemctl status sshd. So now let's go to the testing procedure. In this step, we need to use both machines, which is the client and the server. In this first step, we need to use the server machine. So, run this command to get the IP address assigned to the network interface of this server. The next step, we have to use the client machine. So, we need to run this command to establish the SFTP connection to the machine at IP address 10.0.2.15 using the username grp7sftp. If the connection is successful, it will display connected to 10.0.2.15. Next, create file named group7.txt using command touch group7.txt. And then, to check if the file has been successfully created, run command ls. As you can see here, the group7.txt exists. Next, make a connection with the server machine using this command and enter the password. After connected, run command pwd to get the remote working directory. After that, we have to copy the file we created earlier, which is the group7.txt. Using this command, it will upload the group7.txt file from local directory to this remote working directory. After finish, we have to copy back the file group7.txt and rename it to grp7.txt using this command, and it will upload the file from this remote working directory to the local directory. To check if the file is successfully created, go to Activities at the top left corner, then search Files on the search bar. As we can see here, the group7 and the grp7.txt exist, so it indicates that we have successfully configuring our SFTP server. So that's all from me. Thank you.
Hi, my name is Sam Chui Bing.
Now I'm going to presentation the last part, which is the web server configuration. A web service is a software system with open protocol that has a unique URL address and maintain communication between two applications through the internet. It allows different applications of device to communicate and exchange data using standard web protocols, regardless of the programming language or platform that are built on. Okay, first we need to run sudo apt update to update the local package index with the latest change made in the responsibilities. Okay, after update, we need to run the sudo apt upgrade to upgrade the system for security and bug fix. Okay, after finish update and upgrade, we need to start install Apache 2 using sudo apt install Apache 2. Okay, it can show that our Apache 2 already installed. This Apache 2 is an open source HTTP server software that allows Linux system to serve web pages to users over the internet of a local network. Then run the command sudo apache 2 version to view the Apache version and also to make a confirmation that Apache 2 already installed. Okay. This is the version for the Apache 2. After that, to check the status of the Apache 2 service on the Linux system, we need to run the command sudo systemctl status apache 2. And it already showed that our Apache is already active. And just press Ctrl C to exit it. After that, we need to install the UFW, which is the uncomplicated firewall using the sudo apt install UFW. After install the UFW, we can run the command sudo UFW apps to display the list of applications with predefined profile available in UFW. Okay, this all is a list for the application with predefined profile available in UFW. To active the UFW, we can using this command sudo UFW enable. Okay, now our firewall is active in enable on system startup. And to check whether the status is active or not, we can using the sudo UFW status. And we can show that the status is already active. And all of this list is that we already allowed the UFW, which is called the www and the active TCP 443 TCP 22 TCP. and then run this command to create a directory. The OS project group 7 is our domain name. Press enter to create a directory. After that, to change the ownership of the directory and all its file and the subdirectory to the current user and group, we need to run sudo cron. After that, to change the permission of the directory and all its file to 755 means the 7 it means the owner has full access like read, write and execute. And for the 5 is for the group and others users at read and execute permission but cannot modify the file. Now we need to run sudo chmod. To create and open the file name index.html, then locate at the directory that we create before, we need to using this command, which is the nano editor, and press enter to enter it. Okay, this is the HTML code that I already created before. We just press the Ctrl O to save and Ctrl X to exit. After that, we type sudo nano again for this configuration file. It is used to open or create a visual host configuration file for Apache Web Server. This file defines the setting for a specific website host on our Apache server, and then press enter. Okay, we can show that this is the configuration block that we already insert inside. And we just press Ctrl O to save again and Ctrl X to exit. Okay, after that, we need to run the command sudo a2 enable site OS project group 7 that configuration file, and then press enter. We can show that this site is already enabled, and we will continue types the command with systemctl reroute apache 2. This is used to rerouting the Apache service, and press enter, and we type our password. Okay. After that, we run sudo a2 disable site 000 default configuration file. Okay, it already showed that this site is already disabled. And also run again the systemctl reroute apache 2 to rerouting the Apache service, and type again the password. After that, run the command sudo apache ctl config test to check if there are any error in the Apache server
configuration file that might prevent Apache from running properly. Okay, if there is no error, it will display this syntax OK. After that, run sudo systemctl restart Apache 2. It is used to stop and then start again the Apache web server. This ensures that all configurations are fully reloaded and applied. Okay, after this is our configuration part. Okay, now we need to test that our Apache is running or not. First, go to the activities and search and find the Firefox and open it. Okay, after open the Firefox, at the search bar, we type our IP with our server IP, which is 192.168.1.154, and then press enter. Okay, now we show that success the OS project group 7 visual host is working. This is that one we just now create inside the Nano editor. This is all about web server configuration. Okay, this is all our demo for our project. Thank you for Dr. Marija to pay your attention to look for our demo presentation. Please don't forget to like, subscribe, and open your notification. Thank you.